Okay, so in this video we will talk about the third law of thermodynamics. So we had already discussed on the first and the second law, and in this video I will give you the definition, the statement of the third law of thermodynamics as well as the zeroth law of thermodynamics. Now in third law of thermodynamics, what it states that the entropy of a perfect crystal at absolute 0 Kelvin is exactly equal to 0. Now, we had already discussed what is entropy. So you need to understand entropy and what do we mean by absolute 0. Here we are talking about the temperature, okay? The temperature that which is measured in Kelvin. Now just take a look at this diagram here. I had given this example when we talk about entropy. So what you can see here in solid, the particles, okay, they have less freedom of movement. They are moving, but they have less freedom of movement as compared to the liquid. And as you go this way from solid to liquid to gas, the gas, they are more random as compared to the particles or to the molecules. In case of solid, they have more freedom of movement. All right, they can move freely everywhere. They are more random. So entropy is nothing but it is the measured or of disorderedness or the randomness of the molecules or the particles in a system. So here what happened, we know that when the energy is added, the entropy it will increase. As we go from solid to liquid, the molecules, they will, if you add energy, they will gain more kinetic energy and they will start moving faster and more randomly. Okay, they will be distributed more randomly and they will move faster as compared to solid. But if you move this way, the entropy, it decreases. Why? Because you remove energy. So just remember, as you remove energy, the kinetic energy of the molecules also will become less and less, and the particles or the molecules, they will become less disordered. All right, they will become ordered, more and more ordered as you go this way. So the entropy, it decreases. But as you go this way, the entropy increases, and that is the second law. Actually, it is the second law of thermodynamics, which stated that the entropy of the universe tends to increase. So here, since we are talking about the third law of thermodynamics, now you understand what do we mean by the entropy. So what it stated here, that the entropy of a perfect crystal, that means a pure crystal, all right, the entropy at absolute 0 Kelvin, that means at a temperature of 0 Kelvin, is exactly equal to 0, meaning the entropy, if you remove all the energy, all right, if you remove all the energy of the molecules, then they will stop moving. All right, movement of the atoms or the molecules does not occur at 0 Kelvin. So here we can see that the microstates are limited to 1. That is the orientation in which the molecules or the atoms are allowed is limited to 1. Okay, the microstate, it is the orientation for the atoms or the molecules which are allowed to have. Okay, so to understand this, what do we mean by the absolute zero or the microstate. All right, to understand entropy as well as the absolute zero, it is best to introduce the concept of microstates. Now, a microstate, it can be defined or it can be represented as all the possible ways in which these atoms can be placed into different energy levels. So, to understand that, I will just give you an example here. Alright, try to understand this one. Suppose we have a system and there are 3 levels. Okay, in a system, there are 3 levels, and imagine 3 atoms occupying a system which is divided into 3 connecting rooms or levels which have a different energy levels. Okay, now each level is a different energy level. Now, what are the possible ways by which you can have, okay, which you can arrange, okay, the possible ways in which these atoms can be placed into these different energy levels. So, the first way by which you can do is you can place all the 3 atoms in the lowest energy level. This is the lowest. Alright? Or you can also place these atoms in one of the other two. Okay, in one of the other two. Suppose you can place these 3 atoms in the medium, okay, in this middle one, or you can place these 3 atoms in the highest energy level. So you can see that there are 3 possible ways by which these atoms can be placed. So that means there are 3 microstates. Okay, 3 microstates, that is the possible ways by which these atoms can be placed. Alternatively, you can place 2 atoms, or you can do like this. You can place 2 atoms in the lowest energy level and 1 atom in the middle, okay, in this medium one. If you place like this, you will have 6 more possible ways or 6 more microstates. Alright, or you can do like this. So I will not show all, but try to understand. See, you can do like this also. So there will be 6 possible ways by which you can do like this. You can place 2 atoms in one of the level and the other atom in another energy level. So here you can see there are 3 possible ways or microstates. Here there will be 6 microstates and so on. And finally, you can place only a single atom in a single microstate, in a single energy level. I can even do that. Suppose this is the first atom, the second atom here, and the third atom you can place here. So if you do like this also, another way you can place the first atom here, the second one here, the third here. So if you arrange like this, there are 10 possible ways by which you can place these atoms in different energy levels. So we can say we can have 10 possible microstates in total. Alright, so why I'm giving you this example? In order to understand that when absolute zero is here, when absolute zero is reached, that means all the energy is removed. Okay, it is brought to 0, the temperature is brought to 0 Kelvin. So at absolute zero, what will happen? When absolute zero is reached, all of the atoms, they must be in their lowest energy level or microstates. Okay, that means all the atoms will be in this position. If you bring down the see in this diagram, if you remove energy, you know that the entropy decreases, right? So what happens if you bring down the energy or the temperature to 0 Kelvin, then all the atoms, they will have lowest energy level or lowest microstate. So they will be arranged in this lowest energy level. In that case, it will result in an entropy equal to 0. Then the entropy will be equal to 0. How? Because if you remember, the mathematical definition of entropy was proposed by this person, Ludwig Boltzmann. All right, by this person, and it was given by entropy equal K log W, where S, it is the entropy of a system. All right, a system. Here we can see any system, whether it's element or compound or anything, entropy of a system. K is the Boltzmann constant. It is a constant, all right, and its value is 1.38 into 10 to the power minus 23 joules. Okay, and ln, it is the natural logarithm. All right, then we have W. Here W, just remember, it is the number of possible arrangements. The number of possible arrangements, or we can say the number of microstates of a system. So just now I had given an example here about the microstate. So that will be your W. So here in this case, like I said, when all the energy is removed, when the temperature is bring down to absolute 0, then all the molecules or the atoms, they will be at their lowest energy level. So that means there will be only the number of possible arrangements, or the microstates here will be 1. Okay, only this one. So what happens if you keep that in this equation? Then entropy will become K, which is this value, 1.38 into 10 to the power minus 23 log of 1. So 1.38 into 10 to the power minus 23 log of 1 is 0. So this 1 into 0, it will be 0. So you can see, what do you get here? Entropy equal to 0. So that is the meaning of this one. At their lowest energy, just remember, at absolute 0, you can see that at absolute 0, what happened? The movement of atoms does not occur, and the number of microstates are limited to 1. You can see here there are 3 possible microstates, here 6, and here 10 possible microstates. But what happened when all the energy is removed, at absolute 0, then we will get only this possible microstate will be 1, because all the atoms, they are at their lowest energy level. Because if we go this way, you can see when you remove energy, the entropy will decreases. The kinetic energy of the molecules will be less and less, will become less and less if you remove the energy. The movement also will be, the movement of atoms will be less. Or we can say that the molecular disorderedness becomes 0. So when you calculate also, you will get the entropy as 0. So I hope that is clear, that the third law of thermodynamics, it states that this entropy of a perfect crystal or a pure crystal at absolute 0 Kelvin is exactly equal to 0. Alright, so in the next video, I will talk about the 0th law. I will give the statement of 0th law of thermodynamics.